Hi. Exam 1 review. So, we have chapters 13, well, technically 12, but 13 and 14. Chapter 12 is used throughout the entire Calculus 3 course because it contains concepts on parametric equations and polar coordinates, which are both used through all of the chapters we have. So you are going to see those concepts as part of a problem, not the problem. We're looking we're looking at 10 problems. Most likely there will be no parts to any of these problems. I mean, there might be one problem or two problems with parts A and B, might not, I don't know. But you're not going to have 10 problems and each one has 5 parts, so it's 50 problems, you know what I mean? So it's 10 problems and then 1 or 2 might have A and B, something like that. Sometimes I do ask for you guys to state a formula or something like that. An example is state the formula that calculates the angle between two vectors. State the procedure to calculate the cross product. So, you know, some of that basic stuff. What is the vector valued function? It's some of that's considered like a gift question, because obviously if you don't know those concepts you can't do anything on the exam. So 10 problems and maybe 1 or 2 with A and B or so, something like that. Those of you who are wondering, yes, there is partial credit, because we all know that partial bridges and partial buildings all stand. What else is important? No bathroom during the test, obviously, so go before and then after the test. Anything else? Housekeeping? You know the policy in the syllabus. Hopefully you're doing those quizzes. You have 1 tonight, 1 tomorrow. So there's that. And the topics and the ideas that, right, you really need to know. So working with vectors in R2 and R3. Guys, this has a whole bunch of being able to graph the vector, being able to add, subtract vectors, all of that. The terminal point to obtain a vector by subtracting 2 points. Vectors are free to move in space. All of that stuff. So working with vectors would be the first in 2D and 3D. So technically that's your first 2 sections. And then we have the dot and a cross product. We finally get to lines and curves in space. So when you say lines, we say find the equation of the line given. Find the equation of the line given, and then you have given stuff. How about that? So to find equation of the line, you can be given 2 points. You remember what you do with 2 points? you make one of those a fixed point, right? And then you do the subtraction to get the vector v, and then you use that fixed point, which is x0, y0, z0, and the vector v to come up with the three equations. The line could be parallel to something, meaning to another line. Well, if the lines are parallel, then they have the same v vector. The lines can be perpendicular, and if the lines are perpendicular, then you can figure out the vector. Whatever needs to dot into it, so you can get 0 and a dot product and so on. So find the equation of the line given stuff means you can have any configuration to find the equation of the line. Oh wait, this is not curves, this is planes in space. Lines and curves in space, it's whatever. Number 4. Plane in obviously R3. So that will be find the equation, right? So find the equation using find the equation given, there we go, 3 points. You know that you are supposed to use those 3 points to come up with the 2 vectors, and you cross those for the normal vector. Normal vector is your ABC for the plane. Also basic equations. To create a box, so we did talk about one wall being x equals 0, and then the parallel wall to that wall would be whatever the y value is, and so on. Vector z equals 0 would be floor, z equals 10 was the ceiling for the classroom, and so on. So basic equations: x equals a, b equals c, no, x equals a, y equals b, z equals c, meaning, you know, parallel planes and so on. Number 5. So we have cylinders and quadratic surfaces. And I'll add the ball over here, or the sphere. This could be one of those multiple choice questions to match the shape to the equation, or match the equation to the shape. I give you, few of those and you match them, right? That could be it. You don't have to go crazy memorizing all of the quadratic surfaces and all of that kind of stuff. I mean, you can, it's beneficial, but it's not really determining whether you pass or fail the test, whether you memorized all of the equations or not. But once you see the equation, you must have the skill of eliminating one of the dimensions one at a time, and realizing what shape you have in that true dimensional intersection. We did a lot of that with cutting the ellipsoid into all of those ellipses, and I also called it a watermelon, right? You cut paraboloid, you get either circle and ellipse, but then the other way you get parabolas, and so on. So being able to work with a trace and stuff like that. So this is like these 5 concepts are the concepts from chapter 13, and then we're moving into chapter 14, which is on the vector valued functions. So define vector valued function. Also in this compute, I'll call it a VVF, a vector valued function. I'll put here a VVF. So compute VVF at t equals a value. And then understand that VVF is the set of parametric equations. So VVF equals set of parametric equations. Number 7, calculus of vector valued functions, and that breaks down into limits, derivatives, and integrals. I'm just gonna put plus C with the arrow because, and in blood, because it's killing your grade when you forget it, right? Make sure you have plus C. All of these are done term-wise. So you will deal with the x equation separately from y, separately from z. Concept number 8 is going to be motion in space. Which is literally application of calculus of vector valued functions. You know what? Maybe I should. Motion in space, and then I'm just going to say able to differentiate or integrate to get r prime, which is velocity, r double prime, which is acceleration, right? So that's what we have, motion in space. So if I give you, let's say, a position function r, which is given as those 3, then you should be able to differentiate term by term and come up with velocity and differentiate one more time. Please remember that speed is the magnitude of velocity. So speed and velocity are not the same thing. Velocity is a vector. It has the direction, right? Velocity limit would be, yeah, you also get to pick the direction. Speed limit, well, hopefully you're moving with the traffic, right? So speed is the magnitude of velocity. I can put the arrow above velocity because that's a vector where your speed is a scalar value. Number 9, length of curves. We have 3 different ones. But then the first one we covered was technically calculus 2. So we have that L is integral a b square root of 1 plus f prime squared of x dx. So that's the one from Calc2. And then you have your parametric form a to b square root of dx dt squared plus dy dt squared dt. And finally polar integral a to b square root of f of theta squared plus f prime of theta squared d theta. So those are the three formulas. Now the chances are 90% that you're going to have one of these two, and 10% that I'm going to put a Calc2 one instead of the ones that we learned in Calc3. So that was point number 9. Number 10, curvature and normal vectors. You don't have to worry about the physics portion of it in terms of decomposing acceleration, but you need to be able to calculate the curvature, and you need to be able to calculate the normal vector, as those calculations are needed for the rest. So apparently I have 10 points over here and 10 problems, so maybe one per, I don't know. That's going to happen tomorrow if I don't drink this bleach. Nice. So that's it. We don't have many formulas. No, I want to rephrase that. We do have many formulas for this one, but then make sure that you know those extremely important formulas like the dot product u dot v. That's extremely important. Make sure you know u cross v. Make sure you know that if you do it the other way, v cross u, you get the same vector with a negative sign, right? I mean, these are the things that you are calculating 100%, right? Cosine theta. Theta equals cosine inverse of u dot v over magnitude u magnitude v, all vectors. Unit vector, vector u divided by its magnitude, that's going to show up for the unit tangent vector, that's going to show up for the principal normal vector. So being able to figure out the unit vector is extremely important. Making sure you know that your tangent hat, right, is r vector prime divided by the magnitude of r vector prime. Then you have the normal vector formula, which is the derivative of tangent vector divided by the derivative of the tangent vector magnitude. So that's the normal one. What else is there? Well, obviously knowing the equation of the sphere, equation of the line, equation of the plane with the A, B, C, and so on. I think, do I have anything else that curvature? Yeah, curvature. What else do we have? Okay, curvature. What else do we have?
Projection. Oh, yeah.
Yeah.
Projection, is that a request?
I don't know, is it?
Is that good?
You really want the projection?
No.
Do I need it or do I want it?
Do you want it?
Well, do we need it? Do you want it?
No. Yeah, you're gonna flip for it? I mean, if you say projection, I'll add it.
No, I think I
Skip it? All right. What else? So, equation for line, plane, sphere. Those are the equations that we covered. Line is in parametric form. Plane and sphere are the entire equation.
Are we gonna need to know work?
Well, those are in a cross in a dot product, right? The work is the dot product between the force and stuff. So, yeah, we don't have to go into the gory detail. The gory detail, right? Would you like anything else? I don't know.
So can you do number 3 of today's quiz, which you probably don't know, so I have it up for you.
It's on the quiz.
Yeah.
No.
It's on the quiz.
You can
Well,
say
what is it
after.
about?
Nobody knows how to do it.
Really? Is that bad?
No.
No one
I
knows.
took a 75 on it, so I didn't have to do
You
that
took
one.
75 on a quiz
70,
because
77.
this problem was so...
I just didn't do it.
Or you don't have to actually do it, can you just go through the process?
So just do the cross product of these two.
Yeah.
And then
I mean, it doesn't make it separately, and that's all I care.
XO plus
I don't know.
2. I think that's what I did. Let me see.
Find both the vector equation and the parametric equations of the line through 3 perpendicular to line. No. Yeah.
Yeah, you just cross those two and then
Yeah.
point, right? Okay.
And the point is at t equals 0, right? So you can calculate the point. Good. Let me also write in blood because it's, throughout the year. Be able to intersect
So it's just
plane and line, two lines, two planes.
okay, that's
Oh, we're using that.
Because those are some basic ideas that you need when you are designing stuff. I mean, are these two walls going to touch and meet, right? It's important. And they meet at that line of intersection. So those are the things that you might want to consider. Don't forget for the cross product that J is negative and I and K are positive, right, as you're solving, and that probably some of your homework examples already went up in flames because of that, and you learned, right?
okay.
Yeah, use that.
Anything else that you might be interested in? No. Any questions, concerns, any problems to do, redo? Other than today's quiz problem, which was a cross product apparently. Yes.
Number 11 here. You have one that's like kind of like a proof. Will there be anything like that on the quiz today?
No, unfortunately. I'm sorry to disappoint.
Sounds good.
But that one is mandatory for the, just do the cross product.
You said 5 problems on the though, right? Correct.
That's definitely not one of them. Right?
You need to,
Anything else?
As long as we did some of the homework problems for each assignment.
We're happy.
there with you, or it's all.
Me
Because
neither.
I knew he was
There you
Why is that?
Because I'm in love with him.
Yes. I mean, the calculus are useless anyway, so.
And you just thought that.
But yes. By all means.
He liked.
You can see 16 of them, no south.
He just come back at my school. In this semester. He transferred to in this
I am specific, yes, the
And
standards
I love
for
it.
calculus courses is not graphical calculus.
And we still talk a little bit. Like he's my second best friend on Snapchat. I'm like, I know him.
So-
I'm like, I just love him. Like, I'm so
If you don't know the
Because he
traits,
lives in
and all
Mississippi
this,
now and he just like
see your.
he's basically me, but isn't me, so that's
That's what these calculus environment, right?
I don't care.
I'm still happy.
yeah, and look at the girl he just left on Instagram.
But I'm heavier, so.
So which one am I changing?
It doesn't
Any
matter.
other questions, concerns?
Doesn't matter.
Tell me this girl isn't me, but
Well,
is,
bye.
looks like me.
Don't even.